Hello everyone. Our lesson today talking about perpendicular and angle bisectors. At the first, as we see here, we have 3 points, B, D and C. Here, if BD, this line segment, equal DC, that means the distance from B to D the same as the distance from D to C, what can we say about that? We will say that point D is equidistant from B and C. This is definition of the equidistant point. Then the meaning of equidistant, if point D is equidistant from point like B and C, means that BD equal DC. Let TU is the perpendicular bisector to the line segment RS. What can we say about T, V and U? Here we will say that T is equidistant from R and also equidistant from S. That means RT equal TS. Similarly, we will find that also point V is equidistant from the two endpoints of the line segment RS. That means RV equal VS, and also the point U equal UR equal US, or RU equal US is equidistant from the endpoints of that line segment RS. Here, our theorem says that if a point lies on perpendicular bisector like this perpendicular bisector, then this point is equidistant from the endpoint of this line segment RS. Then T equidistant from R and S, V equidistant from R and S, and also U equidistant from the endpoints R and S, because they lying on perpendicular bisector to this line segment RS. Here we have theorem 5.2 for the perpendicular bisector. As we said, if a point on perpendicular bisector like this one is perpendicular bisector to this segment, then it's equidistant from the endpoint of the segment. The converse of the theorem, if a point lying on a line like this one, equidistant from the endpoint of the line segment, then this point on a perpendicular bisector. Here, by looking at this example, the given here HF equal HG, and we have line segment FG. What about this H? H here lies on perpendicular bisector according to our theorem, because equidistant from the endpoints of a line segment FG. Here we have 2 points TV and the line segment RS. If T equidistant from R and S, and similarly V also is equidistant from R and S, what can we say about TV, the line TV? The line TV, yes, is perpendicular bisector to the line segment RS. Then here, 2 points and segment lie on the same plane, and each of the 2 points are equidistant from the endpoints of this segment, then the line joining them is perpendicular bisector to that segment RS. Here, perpendicular bisector of the triangle. If we have line, ray, or a segment that is perpendicular to the triangle, to the side of a triangle at the midpoint of this side, like LM is perpendicular and passing through the midpoint, then this line or this ray or this line segment is called perpendicular bisector to this triangle. What about the perpendicular bisector? Should we draw the perpendicular bisector from each vertex? Does it mean if we draw from here, from this vertex, perpendicular bisector, this line will be passing through the midpoint? No, no need. The perpendicular bisector of a side doesn't have to start from the vertex like this one. Here we have perpendicular bisectors, and each perpendicular bisector doesn't passing through the vertex. Like this one is perpendicular bisector to this side, and this one perpendicular bisector to this side, and the third perpendicular bisector to this side. Here each one making right angle and bisect the side. This point of intersection of the perpendicular bisectors is called circumcenter. Here, any point on the perpendicular bisector of a segment is equidistant from the end point of the segment. For example, if we have AB, like this line, if it was perpendicular bisector to the segment CD, then we will find that AC equal AD, because A lying on perpendicular bisector, then this point A equidistant from C and D, then AC equal AD, and also BC equal BD. Here the circumcenter is equidistant from the vertices. The point of intersection of the three perpendicular bisectors, we will find that the distance from the circumcenter to each vertex is equidistant. Like for example, from here, from this point, the circumcenter to the vertex, we will find this distance the same as this distance, and also the same as this distance. Then the circumcenter is equidistant from the three vertices, then the side equal this one equal this one. Here we have another theorem for the angle bisector. All of us, we know that the angle bisector is the ray bisect the angle, divides the angle into two congruent angles. Okay, if an angle bisector like this one, if a point lying on the angle bisector, then this point is equidistant from the two sides and perpendicular. Again, here we have angle bisector, this one. Then any point on the angle bisector is equidistant, the same distance from the sides of the angle. Then this point equidistant this distance, or this length equal this length and perpendicular to the sides. The converse of the theorem, if we have point lying on ray like this one, and we don't know if this ray is angle bisector or not, if a point lying on a ray like this one and equidistant from the sides of this angle and perpendicular like that, then this point lying on angle bisector. Here, let AD, the ray AD, bisect the angle BAC. If point P lies on the ray AD, then we will find that PM, this distance, PM perpendicular to AB, and PN also perpendicular to the other side AC, and both of the two sides are congruent, equal in length, because this point lying on angle bisector AD. Here, as we said, the theorem, if a point like point P lying on an angle bisector like AD, then this point is equidistant from the two sides of this angle. Here we said this distance the same as the length, the perpendicular length, this one here, like this distance 3 here, this is equidistant, that means equal this distance, equal the perpendicular segment, this one. Let's solve this question. If CD is perpendicular bisector to AB, then what about CA and BD, their length? Since CD is perpendicular bisector, point C lying on perpendicular bisector, then according to our theorem, then point C is equidistant from the two endpoints A and B. That means CB, the length of CB equal the length of CA equal 5. Similarly, point D also lying on the perpendicular bisector. Then point D is equidistant from the two endpoints B and A. That means DA equal DB equal 6 centimeters. Using the angle bisector theorem, find the value of x and find the length of FB and FD. Here we have angle bisector. How did we know? Because here in the given we have two arcs to tell us that these two angles congruent. That means CF is angle bisector. Then from point F is equidistant from the sides. That means FD, this equidistant from the other side equal FB. Then we will write 7x minus 35 equal 2x plus 5. Let's solve this equation by moving 2x to the other side and 35 to the right hand side. We will get that 7x minus 2x equal 35 plus 5. By solving this equation, we will get 5x equal 40. By dividing both sides by 5, we will get that x equal 8. Yes. Let's find the length of FD and FB. By making a substitution here, 2x plus 5, then 2 multiply 8 plus 5, 16 plus 5 equal 21. Then the length of FB and FD, each one equal 21. According to this diagram, how far is K from the ray EH? Here, since these two angles are congruent according to the given, then EC is an angle bisector. Then this point K is equidistant from these two sides, because here also we have in the given KH equal KD. Then K is equidistant and equal 10 each one. KH and KD equal 10. What can you conclude about ray EK? What can you conclude about ray EK? Here we said EK, this ray is an angle bisector because point K equidistant from this side and also equidistant from this side. Then the ray EK, this is an angle bisector. How to find the value of x? Since these two angles are congruent as we proved, then 2x equal x plus 20. By solving this equation, we will get that x equal 20. How to find the measure of angle DEH? Again, since these two angles are congruent and we said x equal 20, then by making a substitution here, 2x equal 40. Then how to find all of the angle DEH? Since both of them are congruent and each angle 40, then all the angle DEH equal 80. Thank you for listening and have a nice day.